So we are going to finish up section 7.1. So this is the fourth day we've been on it, but it's technically the third lesson day, like the third day we've taken notes on it. All right, and we are going to be solving trig equations. So you guys have already solved trig equations. You've already taken a test over solving trig equations. These are going to be a little more complicated because you may need an identity to solve them, or you may have to factor to solve them. So we've done those things, just we have never done them together. So down the margin of your paper, we're going to write all the things you need to know to solve a trig equation. One of those things you need to know is the hand trick. So draw a little hand on your margin and then label your fingers with the appropriate angles. All right. And when you're done with that, write down how you use the hand trick to do the sine, cosine, and tangent, please. Bless you. And then sometimes you are going to need the unit circle. So we're going to do the quadrant angles on the unit circle. All right, and then write down how you use the unit circle, to find the sine, cosine, and tangent. All right, so what else do we need to know? Right. So we need to know pi over 6, pi over 4, and pi over 3 in the other quadrant. I forgot for a second. All right, and there's one more thing we need. It's an acronym. All students take calculus. Okay, it's a lot of things. But if you have it written down, then you don't have to rethink it every time. You can just find it on your paper. Now, when we did equations before, They were only sine and cosine equations. But if you guys remember the other trig graphs, they all had vertical asymptotes. Where did they have vertical asymptotes? Like, what made them have vertical asymptotes? Zeros in the denominator. So whenever they were undefined, you had a vertical asymptote. So the places where secant, cosecant, tangent, and cotangent are undefined are going to be quadrant angles. And so we didn't talk about this before because it didn't come up because sine and cosine are never undefined. But with these other new equations we're going to have, you just need to try to remember that quadrant angles might be extraneous solutions. And this is particularly whenever you have to use an identity. So we're going to always just, if it's a quadrant angle, just always kind of just check to make sure it's not extraneous. But it really happens mostly if you use an identity. All right, so just try to keep that in mind. So we haven't had to do that before because we've only done sine and cosine before. All right, so on all of our examples, we're going to find the solutions in the interval from 0 to 2 pi. And we're going to do a bracket on the 0 and a parenthesis on the 2 pi. So we are going to include 0 in our answers, but we are not going to give 2 pi as our answers. Now, it's nice when you're given that interval, you don't have to do the plus 2 in pi stuff. So we don't have to worry about that today. And so all of our answers are either going to be these angles or these angles from, so those are the 12 angles. All right, so here we go. This is going to be a little step above what we did before. So for A, we have 2 cosecant squared of x minus 8 equals 0. So our first step on one like this is to try and get cosecant of x alone. So what would y'all do first? Add 8. Divide by 2. Okay, well, this hasn't come up before, but what do you think you would do to get rid of the square? Square root. Now don't forget that every equation that you solve by taking the square root, you have to do the positive and negative square root. Even if it's a trig equation, you still have to do that. Okay, so that was kind of new. There's another thing that's new is this equation is cosecant. We haven't done one of these yet. So we don't have a hand trick for cosecant. So what I would do is just rewrite it as sine. So cosecant is the reciprocal of sine. So if the cosecant of x is positive and negative 2, what would the sine of x be? Yes, the reciprocal of 2, which is 1/2. Okay, so you would need to do that for cosecant. If it was a secant equation, you change it to cosine, and then cotangent, you change it to tangent. But I always wait to the very end to do that. Okay, so what does this 1 tell you if you're going to use the hand trick? One bottom finger. Okay, and this is new too. What quadrants are we talking about? All of them. Yes. So if you have plus or minus, it's going to be all 4 quadrants. All right. So what finger are we talking about? Pi over 6. So we're going to do pi over 6 in all 4 quadrants, which we've already written down. And then as long as we didn't get one of these angles from the quadrants, then they're not going to be extraneous. They're perfectly fine. That's it. All right. Any questions? Okay, let's look at another one. So for B, we have tangent cubed of x equals tangent of x. Right. So this last one, we had a squared term, but we didn't factor it. So you only have to factor if you have like a square and an x, or it's a regular, or you have like a cube and a regular. So this would be like if you had x cubed equals x. So what you would do is get everything on one side so you can factor it. So how are you going to factor this? Right. Factor out a common factor, which is the tangent of x. Right. Okay, so try to think back to when we were factoring a long time ago. After you factor, then what do you do to solve? After you factor, what would we do now? Set each equal to 0. If these multiply and give you 0, it means one of them has to be 0. That's the only way you can multiply and get 0, is to multiply by 0. Right? Then you have 2 more equations to solve. So this one, we're going to hold off on it. We don't really need to do anything. The other one, we are going to do a little algebra. All right. So if we have that the tangent is equal to 0, where are we going to go? Over here, the unit circle. All right. So what I want is to be able to divide y by x and get 0. So that means in this case, y needs to be 0, and x can either be 1 or -1 because they both give you 0. We want the y to be 0. So 0 and pi. I did that one wrong earlier for some reason too. Maybe I worded it weird, but it's going to be 0 and pi. Okay. And then we want to find the angles that have a tangent of 1 or -1. Can they come from the unit circle for tangent? Mm-mm. So on tangent, you're dividing the y by the x, the y by the x. That's never going to give you 1. It's either going to be 0 or undefined. So we have to figure out this hand trick thing for 1. Exactly. So, whoa. So we want the same number of bottom fingers as top fingers to get 1. All right, so that is going to be pi over 4. What about quadrants? All the quadrants. Okay, so we're looking at pi over 4 in every quadrant. This one has a lot of answers. Now we did get 2 answers from the unit circle. So we just need to make sure that we can plug 0 in and it doesn't give you something that's undefined. And it doesn't. Like the tangent of 0 we already know is y divided by x is 0. The tangent of pi we already know is y divided by x is 0. So this is fine. So like I said, it's going to be more of a time when you like use an identity and tangent disappears or cotangent disappears.
So it's all the quadrants.
Yes. All right. So that's almost every, well, no, just kidding. It's every quadrant, and then 2 quadrant angles. It's a lot of it. Okay. So next one is kind of a big step up. We are going to have to use an identity on C. So for C, we have 2 cosecant squared of x plus cotangent squared of x minus 3 equals 0. All right. So if you have 2 different trig identities, you're either going to have to use an identity or it would be factoring out a common factor. Does this one have a common factor? No. So this is going to be an identity. So we have to rewrite them with the same trig identity. And so looking at the identities, I think it's definitely easier to rewrite cosecant of x as some kind of cotangent of x. Do you guys see which one? What does cosecant squared equal? 1 plus cotangent squared of x. So that's one of your Pythagorean identities. You do not have to memorize that one. It will be available to you. All right, and then we're going to do some algebra. So we're going to distribute. All right, and then we'll combine like terms. And I don't know if you guys have ever added 2 cotangent squareds and plus another cotangent squared, but what do you think that'll be? 3 of them, yeah. Now that takes us to a problem similar to the first one we did. So kind of the same steps. We're just going to use some algebra to get cotangent alone. Okay, so the cotangent of x. Now I am not going to reduce this. There's a couple of reasons. Like if it was actually tangent here, the tantric you're doing tangent when it's not reduced. So just leave it that. Like if this had been tangent, just pretend that would mean there would be 1 bottom finger and 3 top fingers. It's not, but that's what you would do. So don't reduce it. But it's cotangent. So what should the tangent of x equal? Right. And if you wanna make it match the hand trick, you would put that over 1. So this time we want 3 bottom fingers and 1 top finger. And then what about your quadrants? All quadrants. All right, 3 bottom fingers, 1 top. Looks like pi over 3 to me. So pi over 3 in all 4 quadrants. Okay, so all of those you can plug into the original problem and it all works out. still have a couple more examples. I know it's a lot of examples today. It's just, these are all so different. I don't want you to get confused when you go to do your worksheet. This next one, if you're pretty good at factoring, it's easier than that one, I think. So we have 2 sine squared of x minus sine of x minus 1 equals 0. Okay, so this one there's not a common factor. We only have sines, which is good, and there's 3 terms. So we're going to factor it like a normal quadratic, or a normal trinomial, sorry, where what we put there and there needs to multiply to give us 2 sine squared of x. Very good. That's the only option, so it has to be right. What do we know about our sines? They're different. So I am going to go ahead and just do plus minus. We may have to switch. We'll have to wait and see what happens. And then what we put here and here needs to multiply to give you 1. The only option is 1 and 1. Now, the only thing that might be wrong is we may have to switch the signs, but I don't think so, actually. So when I multiply, whoa, let me try that again. When I multiply that, it's negative 2 sine of x. That is sine of x. What do you get when you add those? Negative sine of x, which is what I wanted. So, high five. All right. So now we'll set each of these equal to 0. And then we have these 2 equations are kind of like what we did the first time we learned this. Nothing super weird about them. Okay. So for the sine of x to equal negative 1/2, I'm going to want 1 bottom finger. What quadrants? So since its sign is a negative, that happens in quadrant 3 and 4. So 1 bottom finger is correlated to pi over 6. So pi over 6 in quadrant 3 and 4. What about sine of x is equal to 1? Unit circle. All right, and when we're finding the sine, we're doing the y coordinate. So what we want is the y coordinate to be 1, and that should be pi over 2. All right, y'all good? Okay, this last one is going to involve some identities. All right, so for E, we have the cosine of pi over 2 minus x in parentheses plus the cosine of x times the tangent of x is equal to the square root of 3. Kind of weird. So if you're thinking in terms of identities and you see this, hopefully it should trigger your brain to go to the cofunction identities. So what is cosine's cofunction? Sine. So drop off a co. So the cosine of pi over 2 minus x is the exact same thing as the sine of x. Okay. Well, it's not really a lot we can do the way it is now. What can we do though? You can change tangent. What would it be smart to change it to?
Sine over cos.
Yes. Cosine does cancel out. You guys finish it from here, please. So you just add those signs to get two signs, and then solve it from there. So this is one of the situations like I was talking about where the tangent kind of disappears. So if these had been quadrant angles, you definitely want to check to make sure something weird doesn't happen. All right, so what questions do you guys have? Okay. Let me know if you do afterwards.